Anyone else tired, chat? Any sleepers? Pog. Oh, good morning. What's the time for me? It's 6:30 a.m. 6:37 actually. Yo, what's up? How's it going? Got some big plans today. Some real stinking plans. Uh, do you see Point Crow's subathon though? I made this timer. I think it's sick. No one's subbing, so you can't see the cool animation it does. Wait. Let me show you. He's posted it on his Twitter. Watch. Oh, so cool. Really proud of that. I think it's sick. There's a really small chance of it, like the normal amount is like 0 to 60 seconds per sub, but there's a 1% chance of it being 5 minutes. So technically, if it has, if someone gifts like 100 subs, then the maximum would be 500 minutes. So it could go up to 8 hours for 100 subs. Also, there's a 1% chance of it being minus 1 minute. So the timer goes down. Ooh. Pog. Yeah, cool. Very cool. But you know what you're here. We all know that everyone here is here to watch me make a new version of r/plays. Janai, thank you for the 7 months. Tier 1. Their type, thank you for the 10 months. And Scarlet the Hamster, thank you for the prime. Appreciate the primes. Yeah, so r/place. I was like, I think last stream I was literally talking about, how I would do r/place if I had to do it, and then good old Ludwig pings me on Discord. He's like, "Yo, can we get r/place done by the end of this month?" And then I was like, "No." And then he was like, "Okay, we can move it to the end of this summer or something," which is slightly better. Much more doable. Okay. So, we gotta think a lot about this. We're gonna build an entire huge service that tens of thousands of people are probably gonna be using at once. Not Walks D, thank you for the prime. We have to make sure that we do it right. That means we bring out the GIMP so that I can draw. All right. So, r/place. We need the... Oh, God, that's so small. We need the canvas. Very important. Canvas. This is what's displayed to the user in their web browser of choice. You can draw pixels on it. Yeah, good little canvas there. And then we need some kind of connection to the back end. This is the back end. BE for back end. So this could either be WebSocket or it could be polling. Probably not going to have it be a WebSocket because those are just... I don't like WebSockets anymore at the scale. And the backend has to be like a bunch of little backends that all communicate with each other through like a Redis instance. Probably. So like 15 different backends so that one of them doesn't get overloaded. Horizontal scaling. So there's only two parts, the front end and the back end. The front end's going to be easy. I just have to make a large canvas and then draw pixel on it. Should be fairly simple. The back end is going to be very hard because this has to handle 10,000 requests per second. And they all need to be coordinated in real time. And it should probably handle up to 100,000 requests per second, just in case. So I don't know. We could work on the front end. We could do a little bit of front end work. But I also want to think about what the communication protocol is going to be. So like, how am I going to transfer pixels? What are these messages going to look like? Well, I just created a project called Place Backend, but I think I'm going to do the front end right now. What am I going to make this in? React? Am I going to make it in Svelte? Probably either would work. I think either React or Svelte would work for this. It's going to be a production project, so I can't... But it's really simple. It's just like a single canvas. So actually, either the casing around it doesn't matter a lot. We got 2 votes for React, 2 votes for Svelte. Okay, I'll make a poll. What front-end framework, Svelte or React? Everyone wants React, I guess. Okay, since we voted React, I'm now going to be reacting to a video. Any reactors? Actually, I do want to react to a video that I saw come up by one of my favorite niche channels. I'm not sure what it's about. Oh, fuck. I need to make new templates. This one uses MUI, and I don't really want to use Material UI. I want to use, like, Tailwind. I'm a Tailwind man now. Okay, well, chat, if you are getting into React, here is your chance to see what my setup looks like. This is a React tutorial now. So, welcome to React. First off, we're going to install some Tailwind. Hell yeah. We're going to install Tailwind CSS. And then we're going to do npx tailwind CSS init to create a Tailwind config file. And then we're going to, we're going to install some twin macro. It kills me that he still uses yarn. Why do you not like yarn? Then we're going to install this stuff just by copying from this file. We got React server style. We need to add emotion CSS and ooh, slow there. Yarn is a way of installing JavaScript packages. There are several ways of doing so. The most common one is probably npm. Twin.macro. Is this a Ludwig project? Yeah, that's why I'm in the Ludwig directory. I have a Ludwig directory. Who doesn't have a Ludwig directory? Just a bit of yoinkage. And another little yoink. Okay. Sounds like we need some styles. Yoink. Should try Yarn PNP. That's like Yarn v2, right? Maybe I'll set up a template for that later, but okay, so far so good. Now we have to do, I think we have to do some little config stuff. Yeah, we need this twin.d.ts and make this file. Boom. Wow, coding is easy, chat. Coding is so easy. Am I good now? Let's see if this runs, I guess. Cannot resolve file system. What? Shit. That's not good. Wait, how could it not? Fuck. Oh, I need to use Babel. Babel, Babel, Babel. Okay, don't share your videos here, though. You're not allowed to. Okay. There we go. There's a little place front end for you. Except I don't want this. I don't want MUI material. I thought I'd removed that. Okay, this isn't working. Doesn't Ludwig pay all his employees semi-randomly? Yeah, I'm gonna probably ask for a raise sometime soon. I've learned. I've been talking to some people about salaries. Although I am. No, you know what? Yeah, I need a raise. Ludwig, you here? Oh, I need to install this thing. I'll do that. Oh, do I have to do? Oh, there we go. There we go. We're ready. Oh, I need to do this thing. Wait. Hold. Yarn. Add D. Babel. Plugin. Twin. Go to the Babel. Add this. Cool. Yarn dev. Get rid of this. And then we could do like text red 400. Nice. All right. All good. Okay. Time to get started on the front end. So we need to make a big canvas. That's generally the first step in doing r/place is a big canvas. So we'll do a little canvas, make it a little component. And inside the canvas is going to be, shocker, a canvas that is 1,000 pixels wide and 1,000 pixels tall. Although maybe we should do like 250 for testing purposes. Maybe we should just work with a 250 by 250 canvas for now. And then we want to put this on the page. Okay, wait. My Spotify is being fucky. Hold up. So we're just going to draw a single little canvas. Okay, there's the canvas. That's fairly small, actually, if you think about it. Did I read Reddit's blog on how they did it from 2017? No. You can link that to me. I'll probably scan over it. I'm going to put it at 1,000. No, I'm going to put it at 500. Okay. Okay, how we built r/place. Very large. 100,000. Oh, that's what I was going to do. Captain Sync. The main challenge for the backend was keeping all the clients in sync with the state of the board. Yeah, for sure. Solution was to initialize the client state by having it listen for real-time tile placements immediately and then make a request for the full board. The full board could be a few seconds stale as long as we also had real-time placements starting from before it was generated. Sure, that is cool. That's actually a good insight. Our initial approach was to store the full board in a single row in Cassandra. Each request would read that entire row. The format for each column in the row was this. Timestamp, author, color, cool. 1,000,000 tiles, we had to read a row with 1,000,000 columns. This was up to 30 seconds. Next approach was to store it in Redis. That's what I was going to do. We're concerned about exceeding maximum read bandwidth. But they did use Redis. Well, this is what I was going to do. Cool. That's validating. Drawing the canvas, blah, blah, blah. What did they miss? Pause, champ. I don't understand what this is saying. Okay. Well, this is kind of cool, I guess. All right, back to coding. We have a canvas here that's 500 by 500 pixels. I need something that can efficiently draw several pixels to the canvas. So, okay. I'm thinking we have to write image data. Okay, wait, okay, I'm gonna make this a 5 by 5 canvas for now, actually. And then if I find this here, I'll make it bigger though. And can I do pixel? Okay. So there's our canvas. It's 5 by 5 pixels. And if I do this dot get image, no, dot get context 2D, and then ctx dot get image data. There we are. 4 arguments required, so probably 0055. And there's the image data. It's 1,000 zeros, or 100 zeros. Cool. So this is pixel data. So if I const data equals this, if I do data dot data 0 equals 255, data dot 0 data 2 equals 255, and then 3 equals 255, and then if I do ctx dot put image data data 0 0, there we go. A single pixel has been placed. PogChamp. So now what I'm thinking is, what if I now just do like data.data 4 equals 255, data.data, and then we got 5, 6, 7. And then what if I just do put image data again? This should make the next pixel red. Let's go. Okay. So I don't have to do get image data every time. All I have to do is put image data with the data every time I get the data. Okay, I can do that. So couple things we gotta do here. First off, I want to figure out. Oh my gosh, I want to figure out what this message format is going to be. So we need to send one message up to the server when we place a pixel. And what does this message have? This message has auth data, which should probably be a JWT, so that it doesn't have to do any database calls on the back end. And it has to have the X, Y, and color. Is that all we have to send? Maybe it has to have like a indemnitancy. Idempotency. Some kind of token like that. Who knows? We'll think about it. And then messages we receive back need basically just a list of XY color. A bunch of different pixels. And also a timestamp, probably. Ooh, should each pixel have a timestamp? Maybe an XY color and then timestamp offset. And then this has like a timestamp. So we don't have to store... You have to store a bunch of 32-bit numbers. You store a bunch of 16-bit numbers and then one 32-bit number. Username? Nope. Probably no username. Okay. So I want to make this into a binary format. Is there a library for that in JavaScript? I mean, this is kind of what I'm talking about. Message pack. I like the look of this. I just need an example of how to use it, because there's a lot of API stuff here that I don't understand because I've never used it. Well, actually, unpack pack, pack value, unpack. What is value, though? Can I define my own schema for this? Structures. Shared record structures. Another useful way of using this is storing data in a database if the number of structures away. Okay, structures. What does a structure look like? I don't see. Okay, let's see if there's an example somewhere. Huh. So this is a format. Geller Lurch 86, thanks for the 5 months of Prime. I appreciate it. I don't really want to use this format. I don't want. I mean, sure, this is fine, but I want to use my own binary format because I don't need this shit. Unless there's a way to do a custom. I don't know. Yuki plays, thank you for the Prime. I mean, I guess we could just use this. It's optimized for Node.js usage, but can it be? It can be used on the browser. Okay, let's just do a little test here. Import pack from message packer. And I want to do something like, let's say I want to send a message that I sent, or that I set the pixel 00 to color index 1. Well, let's say 1 1. I'm gonna do console.log pack. I mean 00 or 111. But how's it? I want these to be 8-bit. No, well, I mean, I want these to be 16. I want to be able to define my exact binary format. Okay, good enough. Looking at this has a single extra byte. So if I wanted to put pixel 500, but it's, well, actually no. This is probably fine. This is probably fine. I don't know. I don't know what this format is saying right now. But I guess, is this the best? Yeah, fine. Whatever. This is probably the best way. Okay, sure. This is fine. So if I wanted to do something like pixels is, and then let's say this one is set, and we have another pixel at like 212, and then like 5443, and then timestamp is timestamp is date.now. I guess I could just encode it as an array. Well, okay. We'll just use message pack for now. You love this song? Yeah, this is one of my favorite Tally Hell songs. "2015 Automaker," more like imposter. Chat, I need your help here. Kiebs, thank you for the 2 months of tier 1. Your help is not, by that I don't mean like check if you have a Prime available and use a Twitch Prime if you have it, although that would also be helpful. But does anyone know of any services that do load balancing as a service aside from like AWS? Because I will use AWS if I have to. But there's got to be other projects out there, right? Hetzner. What? Oh yeah, good service, I guess. I will definitely use this. Their website's fucking broken. Okay, anyone else? Oracle. The Cloudflare doesn't use load balancing. You guys don't understand what I'm asking, are you? DigitalOcean, huh? That's actually interesting. Each node is a okay. So with only 10 nodes, we would hit 100,000 requests per second. Yeah, it does need WebSocket support probably. It doesn't need it, but it would be very nice if it did have it. Because then I could just use WebSockets instead of having to use not WebSockets. WebSocket support load balancers. Oh, they do. Load balancers support the WebSocket protocol without any additional configuration. When using WebSockets, the load balancer is special. Okay. 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 I guess. Maybe. Things like server sent events are better for caching. Are they? I mean, sure, but does anyone even use those? Aren't there's like JSON streams? SSE versus WebSockets. Does not support binary data. Cringe. WebSockets it is. How would Lambda help with this? Lambda doesn't support WebSockets. It would be super expensive. So does DigitalOcean have like a Kubernetes service? Yeah. Okay. Okay. I haven't used DigitalOcean for anything other than VPSs. I didn't know that they did all this shit, but it seems pretty cool. So all I need to do is create a Docker image of my backend, and the backend can be a WebSocket. Hopefully. Fuck, I forget how to do Docker stuff, chat. It's been so long. Rust Docker. Alright, make a little Docker file and then just yoink all of this shit. Okay, what's going on here? Run user cargo new. Why is it making a cargo new? Okay, I see what it's doing. Copying this. Oh yeah, I kind of want to use Alpine. Alpine. Okay, rust up. What is my IP? Why is it creating a whole new... I don't understand this. Can't you just have like a simple Docker file? Okay, this is better. Okay. So we need to install this to compile some crates successfully. This is what I want. I want to know why I'm doing this shit. Why am I looking at 15 different things here? This one looks better. But this is using Buster again. So it copies all the files, it builds, and then it runs. No, then it runs. Can I click this? Okay, whatever. How do I do Docker run? Wait, how do I Docker build dot? Okay, it's doing stuff. Oh, failed to pass manifest cargo features. I need to enable nightly features. Should be set at the top of cargo before any tables. Okay, pause champ. It needs nightly version of cargo or Rust. Okay, I need to use a different image, obviously, such as Rust lang / Rust nightly Buster. Oh, what? Whoa, whoa. I actually I actually guessed that right. Perhaps it will work. File does not exist. Well, yeah, that's because what? I changed the file. Or I changed it to place backend, not hello. There's no such thing as hello. Oh, here we are. Place backend. And the other thing I wanted to do, yeah, now I don't need to have this here anymore because for some reason it had it there earlier. Go. Do it. Do it. Okay, then I do docker run docker run docker ls docker container ls. Okay, wait, that's not docker image ls. What is it called? About a minute ago. It doesn't have a name. Is it 7CA? No, that's different. Wait, so what if I do docker build minus t, and then I name this place backend? Okay. And now I do docker run place backend. Let's go. So easy. So easy. Wasn't worried for a second. Okay. Hello world, indeed. So, next thing we gotta do is find a nice little WebSocket framework for Rust. I mean, I don't trust this because it's called WebSocket. Never trust the crate if it's called WebSocket. You know what I mean? If you want to install a WebSocket crate, you can't install the one that's called Web. Yeah, see, what did I say? What did I say, chat? Deprecated. I can't trust it. I can't trust it. I'm so smart. Never trust the named package that's exactly what you want. It's too good to be true. Me, myself, hide. Thank you for the tier 1. Tokyo Tungstenite. Lightweight stream-based WebSocket implementation. Cool. Okay, so how do I do it? Where's the example directory? GitHub. More like get good. Haha. Echo server.rs. Ooh, nice chunk of little code here, eh? Okay. What is an error? An error is io.error. Okay, wait, it's still loading this. Okay, so end vlogger, I don't need that. Address. Args. Okay, address is a string, but that's just this, so we can just copy this. We don't need to get it from args. Let try socket equals TCP listener bind dot await. Okay. Let listener try socket dot expect failed to bind. Good. All right. Does this work? Do I have to install Tokyo for this? I do have to install Tokyo. Why are you complaining? Okay, go. Do it. Cannot find main in Tokyo. What do I need to have some kind of... Oh, yeah, features. I know Rust. I just haven't started a new project in Rust in a while. Pause, champ. Big error mode. I don't know what do I need to do here? I probably need to enable some features on Tokyo Tungstenite. Right? Or I need to... Oh, I need to use not standard.net. I need to use TokyoNet. TCP listener like that. Good. Okay, it says it's good. I'll trust that. Then we'll just copy this stuff. So this is just a TCP server right now, I believe. I haven't gotten into Tungstenite yet. And then I have a TCP stream, which is from Tokyo, not from standard. And then peer address. Just copy this. Can't be wrong with that. And then we turn this into a WebSocket stream by calling accept on it. Stream.await. Handshake error. Let me install, or let me switch to Clippy real quick. And then split the stream. So this is an echo server, so this should echo stuff back to me. Does it compile? No. Why is this a thing? Does it compile now? No. I need to, yeah, stream ext. Yeah, this must be nvlogger trying to make me do info stuff. Does it compile? No, I need to install futures util. Where's the, what version of it? Oh, that's very helpful. Thank you. And run. Any features needed? Good. Okay, it says it's good. So who knows? Okay, now we should start. We should try to do this. We should try to do const ws equals new WebSocket. Localhost ws localhost 8080. Was it 8080? What did I bind it to? 8080. Okay. And then ws. Oh, connected. Look at that. Look at that. Connected. And then ws.on message equals console.log message.data, I think. And then ws.send test. Oh, let's go. It works. Wait, that actually works. PogJamp. It echoed it back to me. Look, it says test. And if I say, like, big test, echoes that back to me as well. Cool. Cool. Okay. That was easy to set up. Now I just have to figure out how to do something that's not just echoing back the same thing. Nice. Nice. Okay. Thinking about this. I need to... I'm probably going to be sending... I don't know if I should write pixels over WebSocket or just read them over WebSocket. How many people can you have connected to one? Probably 10,000, I think. But this is going to be load balanced anyway, hopefully. If people are not lying to me. If you allow writing over a WebSocket, you can't really cache / load balance. Why not? Why ever not? Because every connection has different data? Oh, huh. Sure, actually. Okay. Well, okay. So are you saying that you can cache WebSockets as long as they're always the same data to everyone? Is that a thing? Yeah, that's what I thought, Brain Gamer. You can load balance by having multiple backend instances and routing them to. Yeah, you're dumb. You can do it man. I'm not gonna set up manual. I don't understand enough to set that up correctly. And we said we can't do server side events because they don't support binary formats. I should stop listening to chat, I think. Um, I only want to echo binary messages, though. Yeah. Okay. I think you're just wrong, but I do agree that we could have um we could have a REST endpoint to do writing. I think that's probably smarter. Okay. What was I gonna do? Oh yeah, I wanted to see what happened when I sent just a HTTP request to this endpoint. There's a bunch of handshake errors, but does it still works, right? It doesn't panic the entire server. Yeah, okay, good. Good. I just don't understand how I don't understand how sending write requests over WebSocket is gonna disable any caching or load balancing, because it doesn't. Because it doesn't. You can't cache WebSockets anyway. And we probably won't have session data. We'll just include a JWT on each write instance. RDBC bytes. Bytes. This is useful. Or is there a message pack implementation for Rust? Probably. Okay, yeah. Message pack simple. As always, the original one has many less downloads and it was updated 6 years ago versus this one. I don't want to handle dynamic data structures. This is cringe. I want to handle static data structures. Like, I want to use a protobuf or something, I guess. I don't want to use message pack. No, I don't need to find one that supports Serde. I don't need to use that. God. What is this? Okay. I should just be using protobuf, right? Can protobuf have specify the size of integers? Yeah, int32. Yeah. Yeah. I want to use protobufs, I believe. Bebop is a simpler version of protobuf, but is it supported? By Rust. Yes. Okay. Okay. Can I have an example, please? Ah, here we are. You went 16. Okay, that's used for X and Y coordinates. And then is there byte? That's used for color indices. Cool. Date. Okay, cool. Yeah, Bebop seems fine. Oh, it even has a getting started with Rust thing here. I'm gonna make a new folder, call it schema. Add a new file inside here and call it write.bop. And we'll have like message. Is there a Bebop language support? Okay. Is this actually going to support me? Save file to see diagnostics. So I want to do like one goes to uint 16x to uint 16y 3 byte color. So that is my message for writing a pixel. Oh, and then maybe 4 goes to a big string. Be like a GUID. Off. Okay, that looks pretty good to me. And then I want another one that's called read.bop. And then for reading, we have an array of pixels. A length prefixed array of t values. Array, t's, and alias. But how do I... Oh, I need a struct. And then I need to take out this bit. Can I import this struct from the other file? Oh, it can. Import read.bop. And then I can use a pixel in here by doing a union. Oh no, I guess I can just do... that. Here. Pixels, and then... Can I have an optional type? Yeah, but I don't want it to be... I want it to be optional on the pixel. Can I extend this pixel? Union is a tagged union of one or more. This is or. That's fine. We'll just have another struct, which is pixel. Well, actually, then we don't even need to import this thing. Then we'll have here, we have a date timestamp. Wait, no, this shouldn't be a date. This should be a fucking uint 16. Okay, so I got my read and my write. Now how do I compile it? Getting started with TypeScript. Yarn add bebop. Yarn add the bebop tools. Now I need to add a script. Yeah, I know it's not enough for a Unix timestamp. Duh. Obviously. Files. Can I do schemas / star.bop? Oh, I can have a bebop.json. Ooh. Okay, now I just run bebop c yarn compile bebop. It failed. Can't specify. Oh, I see. So this is a bad example of a bebop file, I guess. Thank you very much. Expected semicolon. Okay. Multiple definitions for pixel. Okay. This is going to be a write pixel, and the other one is going to be a read pixel. It ran. Okay. So now lib schemas. Oh God, just format yourself, please. I read pixel. Okay. Okay. Very cool. Very cool. Very cool. Okay. So now I can do something like this. Okay, I'm going to... What am I going to do? Let's do something that allows me to click on the canvas to just place a pixel. Okay, so when I click on the canvas, let's just console.log ev dot client x ev dot client y. So if I go here and then, oh. Okay, the canvas is there, right? So I'm clicking. Okay, yeah, I'm clicking on it. Okay. So when I click on it, let me actually test this. See if this should work, I think. Yes. Yes, okay. So const pixel okay, const rect equals this. And then const x equals ev.clientx divided by rect.width. Y equals ev.clienty divided by rect.width. And then Math.floor these. And then if I do x, y, 0, 0, and then, oh, did not work. Okay. Why did it not work? Oh, I see. Times ev.current target dot width. Oops. So do I really want to math.floor or do I want to like math.round? Oh yeah, this would be rect.height. Oops. Missing semicolon. Shush. Okay. 3 3 0 0 1 0 2 3 4 0. Oh, it never gets to 5 0. So maybe it's math.round. That's what I'm looking for. 1. Maybe it's steel. Let's make it, okay, step 1, let's make it so that when we click, it will draw that pixel. And I just want to have some temporary code here so it doesn't really matter that it's bad and it calls too many things. But I wanted to data equals ctx.get image data, data.data, and then what pixel is this? This is y times ev.current target dot width plus x. This is the index times 4, and then I plus 3. Oh yeah, 0 to 4 is 5 pixels. You're very right. Probably is 4. And then I want to do ctx.put image data 0 0. Okay. Nice. Nice. That works perfectly. So I just need to send this data up to the server. Okay. Okay, ws dot. That's fine. Close it then. And then I want to do ws dot current dot send. And now I want to pack this data that I have. How do I do that? I want to do write lib/schema is where it is, and then I can do test dot place dot. Oh, okay. Wait. This is easy. Place dot write dot encode pixel is x Y color 0 and then auth. Don't need an auth yet. But this is a GUID. So we'll just pass a random one in. Okay. So I think now, when I click on the thing, it should send a little message. There we go. There's a little message. That looks like a pixel being placed. To me. Are these different? Do these actually have different data? I can't tell. What if I take out the auth? What does it look like then? How big is it? Should be super small, right? Oh, yeah, you can't even see it. That's 11 bytes. Wait, 11 bytes. It should only be 4. It should only be 5 bytes. Bruh. 6 bytes at most. Well, only so much you can do. Yeah, I'm not the first one to make a new r/place. There's like 50,000 r/places out there. Well, how I want to know the logic on why this is encoded so inefficiently. Dates are encoded. Oh. It includes 4 pixel or 4 a uint 32 of body length. Fuck. Oh. And then an extra byte for everything. Okay, wait. So I said it should be 5 bytes, and it's 11. So 5, add 4 to add the body length, and then add 1 for each field. That brings us to 11. Well, can I make it not be this then? Wait, okay, wait, a message. Do things need to be messages? Do I have to send messages? Can I send structs? Because I don't really want to, like, have it be possible to take out one of these things. Right? Struct should say 4 bytes for the length and the 1 byte per thing. So struct should be exactly what I want. Let me refactor this a bit. So if I just call this read. No, okay, we'll do write first. X, Y, color, and then auth. This will just be right. Well, we can still call it right pixel, I guess. Boom. And then read. I still need this pixel, but then read pixel is a struct. And then it has a read pixel array, or a pixel array of pixels, and then a timestamp, like so. Boom. Now we recompile. And now there should be big error mode. So we call this right pixel encode, X, Y, color, and now it should say I'm missing the auth. Auth. Well, let's take out the auth for now. It's a test. That is short enough. See how bright the fires out of us burns. Alright, so now over the WebSocket, we have 5 bytes. Exactly what we need. Let's go. Okay, cool. So now I need to receive read pixel events. This is where I missed Svelte. Maybe we should have used Svelte for this. This would be so much easier in Svelte. I don't want to call get. I don't want to do any of this in here, actually. Canvas context, yeah. Okay, so I am getting a context here, which I don't want to be doing because I already have the context. This is cringe, chat. React is so cringe for stuff like this. I want to use Svelte. I don't need to hold 4 fucking refs and have this function be called every time it renders. It's so annoying. Yeah, but we voted like 30-4 for React because people are stupid. Okay, I'll make this a demonstration, chat. I'll show you why you guys are dumb. I'm not doing a Rust front end. Okay, this works. Okay. Let me real quick. Okay, almost done. Most of this is the same, except just shorter code. Like this can just be canvas, canvas, canvas. Okay. So this is 60 lines of code. This is 40. This is React versus Svelte, same thing. Look how much cleaner this is, chat. Honestly. Look, I don't have to use all these use refs and then canvas.current anyway, WebSocket.current. All that's boring and awful. Much more readable. This is also going to be run faster. Well, actually, it's going to run out the same because it's... No, actually, it should run a bit faster. Revote. Left or right? Which do you prefer? I can fit this one on one screen. Can fit this one on much more than that. Oh, looks like Svelte is taking it for this one. As expected. Well, there should be imports, actually. But only that one. Yeah, that's what I thought, Chad. Not that there's anything wrong with React for most things. And often React is the best choice. But in this case, this is closer to like what I'm doing with this canvas is React isn't like a canvas library. It's a UI library. I only have a single canvas here. React is not designed to do this. Svelte isn't either, but it also does it better because it's closer to vanilla JavaScript. Anyway, switching to Svelte because we voted for it. Totally, totally unbiased vote. Okay, I need to make a new project then. PI init Svelte place front end. Reload. Let me see. Get rid of this. Get rid of this. What? Module loop? What the fuck? Oh. Okay, now we got this lib. I don't even need a components folder. Canvas.svelte. Put that in there. Reload. Okay, I already got this running. Now, the only thing I'm missing is the schema, which means I need to, oh yeah, I need to copy over the bebop files. I also need this JSON. And okay. Oh, oops, I put that in the wrong place. This wants to output to source/lib/same. Yeah, that's perfect. And run it. And here we got our schema. And the canvas, it looks like we are good. Now I just have to draw the canvas. I wonder if there's a bind context on canvas. Svelte bind canvas context. No, it doesn't look like it. Okay. I need to... I forgot to set the width and height. There we are. Nice. See, we're already back where we were. Are we back where we were actually? Are we sending WebSocket messages? Sure are. Cool. Back where we were. Cleaner code. Easier code. Let's set a width and height for this. So the best way to contact me through Twitch chat. And I probably won't answer you if you're cringe. All right, so front end is in place, kind of. I now need to listen to the WebSocket. So when I receive a message, I want to do place dot read pixel dot decode ev.data. And I don't know what's going to happen with this because it shouldn't work. This should not work because, yeah, it's not. Well, actually, I didn't expect this to not work. Let's console.log ev.data. It's a blob size of 5. Bebop WebSocket example. TypeScript. This doesn't have any examples in it. It's cringe. Okay, I don't really... whatever. I'm probably not going to respond to you. Because I'm busy. Also, I'm not your friend. Operations per second. Ooh, so fast. Wow. This .buffer.byte length is not an object. Sure it isn't. I know I'm gonna receive. I want to see what. I know it's a right pixel. I literally know that. I'm trying to figure out what happens if it's invalid. Dumbass. Sorry. Just read my mind, chat, and then you'll understand what I'm talking about. Try dot array buffer. That's an async function. Still doesn't work. This dot buffer dot byte offset is not an object. Yeah, this dot buffer doesn't have a byte offset. About that. What other things do I have on here? Slice is still returns a blob. This is a readable stream. Text type. No. I want an array buffer. Okay, come on, dude. Just give me one example of you actually working in TypeScript, please. You want me to turn it into a uint array? See, this would be helpful if this was actually typed as something other than any. Oh, it is. Wait. Oh, is it, though? No, it is. Why is TypeScript not angry at me for this? Interesting. Okay, that works. Cool. So what if it's a read pixel? Big error. Cool. Okay, so so it throws an error. Is that correct? It throws an error? Yes. Okay, so I can just try catch it then. Okay. So assuming that this is a proper object, I want to do something like message dot, okay, pixels. No, I'm not copying Reddit. People keep on bringing this up. First of all, that's their 2017 version, which is probably worse than the current one. Second of all, I'm not copying Reddit. I'm coding on my own. I've never stolen code from people. Well, from libraries, maybe. I know you mean the backend architecture. That's the same thing. I'm not. I came up with Redis independently, with using Redis independently, but I'm not. No. So for each pixel, I want to do data, which is image data, data, well, const index equals pixel dot, okay, we got color times x, y, x, no, y times width plus pixel dot x times 4. And then we do, let's have like a array of colors, just temporarily. Const colors. Then we'll have red be color 1. And then we'll have green be color 2, and then blue be color 3, and we'll just have that for now. No, not index. Pixel dot color. Index equals color 0. And I'm just going to do this probably because it's more efficient. I could have a loop here, but I'm not going to do that because this has to be super high performance. And I don't actually know if this is more or less high performance, but who knows. Okay, so now, why isn't this giving me big error mode? Oh, warnings. I hid my warnings. Okay, so now if I hypothetically send down a valid read pixel message from the backend over here, it should work. So let's look into that. Okay. Let's install Bebop. Is this the placeholder text for the image? Because the image won't load for some reason. Yes. Nice. What was I doing? Thank you for the Prime sub, Sapanya. Appreciate it. Oh yeah, installing Bebop. Getting started with Rust. Okay. If you plan to use a cargo build script, I don't plan to use cargo for building the code. I plan to use TypeScript for doing that. So I can actually tell this, right, to do Rust. I just have to make it output to the right place, which would be where actually which folder is this in? C-line project. Okay. I'll have to actually I'll just move this. Sound and silence, not the peace and the violence. Okay. Boom. All right. Reopened. So now I want to generate. Output file would be .. /place backend / what? Where should I put this? Source / generated .rs or / generated. Yeah, did it work? Oh, it did, kind of. Rerun that. Okay. Ooh, big error. Okay, now I need to import this shit. And I need to attach this to main. Let's not call this generator though. Let's call this like schema. Okay. All right. I now need to actually figure out how to wait. I need to figure out how to do something that's not an echo server. I have read and write, split sync and split stream. This is filtering. This is filtering out only binary messages, so that's good so far. Then it's forwarding it to a sync. It's forwarding it directly, so I don't want to do that. I want to process it first. Ski Hacks, thank you for the Prime sub. Appreciate it. So back to Tokyo Tungstenite. I need a different example. Okay, what is the difference between this code and the other code that I have currently? Handle accept connection. Okay, this does a bit of error handling. Cool. Accept async, yeah. I also should be just calling accept async. New WebSocket connection, sender and receiver, yeah, write and read. And then it has an interval. And it loops. Tokyo select. I see. Mash message, some message. Okay, I think I see what's going on here. And I do want actually something very similar to this. I want an interval, and I want to be sending the canvas updates every 500 milliseconds or so. So I can yoink and twist some of this code. And the other thing I need to do is I need like a shared buffer. Or I use Redis already. Yeah, I need to use Redis. But I only want to send deltas. So, okay, every time I receive a pixel, I want to write it to two places. I want to write it to a disk database, such as SQL, and I want to write it to a Redis database, an in-memory database. And then do I want to... shit. How's this gonna work? I want to write it to three places? In-memory backup, Redis, like, pending, and then Redis... Ooh. Ooh. Hold up. I have an idea. What if I have multiple Redis... I forget how Redis treats it. What if I have multiple Redis tables, and I make a new table every 500 milliseconds? I don't want to run only one instance of the backend. That would be stupid. I need to make it horizontally scalable. I wish I could run only one instance of the backend, but that wouldn't handle 100,000 people. So this has two advantages. Okay, this is what I'm talking about, chat. This is. Let me explain myself, because I don't know if I articulated properly. So basically, we have a bunch of people. These are all the people over here, and they're sending thousands of pixels. So this is the y-axis is time here. So this is time ticking forward. Right? So pixels are being sent all the time. And let's say this is 0, and then this is 1 second. Right? So what I'm going to do is I'm going to put these pixels in two different places. Number one is the entire canvas, which has all the data that everyone draws on it. And every single pixel is going to be sent to that canvas. And that's going to exist in one place. Right? And then when someone new joins, when someone new connects, this is the new guy. They have really wide shoulders. When someone new joins, we send them the canvas here. But also, we're going to have a bunch of sub-canvases. All the pixels that are set in the first 500 milliseconds get sent to this subcanvas. And all the pixels that are set in the next 500 milliseconds get sent to the second subcanvas. So this canvas ends up being like, you know, like that. And then this one's like that. See what I mean? This gives us two things. Number one, we have a built-in time lapse. A full time lapse of the entire thing is built in because we have all these sub canvases which represent what happened at every point in time. And number two, we send this is remember this is over the course of 1 second. We have two sub canvases per second. We send all of these down to everyone. Every 500 milliseconds, we say, okay, let's collect all of the pixels which happened in the last 500 milliseconds, which corresponds to the latest sub canvas, and we send this to everyone. All of these people get it, and then the next 500 milliseconds go by, collects all the pixels, then everyone gets it. Does this make sense? Anyone not understand? Nice. Good. And in the middle of this whole thing, why not just save the pixels? This is the pixels. This would be saving the pixels. I'm just visualizing it as a canvas. These are the pixels. And this is also just the pixels. Or maybe this one should be an image. And so the last piece of this puzzle is in the middle of this. This stuff is Redis. Probably. Or some other database, maybe. And all of these might be sending, like there might be, let's say there's 3 backend servers. There's one like here, here, and here. Some people are sending their pixels to different backend servers, right? Like there might be a guy here that's sending it to this one, and then this one routes it to the correct time. And there's like one sending it up to here, and this routes it to the right one. And then if someone's sending it from here down to here, and then it'll go back up to here. So we can have as many of these green things as we want. And then these route it all to the big Redis instance. So that's the plan. I think this makes sense. Only thing I'm worried about is the Redis instance being so fucking huge and big. How are Delta updates sent to clients? I told you, every 500 milliseconds, we send the most recent canvas to everyone. Wait, this doesn't need that much memory. Because we don't need to store transparent pixels. This is basically a transparent image. It's not an image at all, though. It's just pixels. Like, it's just a collection of pixels. But this is... The background of it is transparent. We don't need to send all the white... We don't need to store the fact that, nope, the other pixels didn't change. Right? Got some questions. How are Delta update? Oh, answer that one. You don't have to send the updated canvas every 500 milliseconds. You can update the database that often. Well, I could. I will update the database as often as I'm going to send it. I think it makes sense to do that. Then okay, well, let's say this runs for 24 hours because that's one of the advantages of r/place. It doesn't have to be running 24/7. It's only running for a short burst of time, right? So if we have, let's say we have 100,000 people connected. And every single one of those people writes a pixel every 5 minutes, which is the maximum throughput. So if we were running for 24 hours times 60 minutes times 60 is a day. Divide this by 5. That's how many pixels each person can place per day. So this is the upper limit. You can place 288 pixels per day. Is that true? It's just not true, is it? Oh, it's 5 minutes, not 5 seconds. Huh. $288. Okay, I was a bit worried there. So this is the 28 million pixels per day at max. Each pixel is 5 bytes. For X, Y, and color. So times 5. Uh-oh. This is a big number. Wait, this is not that big of a number. 144 megabytes. What? Only 144 megabytes for all the history. Am I being stupid here? That's not that much. That's not that much, chat. And this is if there are 100,000 people placing pixels on cooldown. So it'll probably be more like 25 megabytes. Now, there is going to be a bit of extra overhead. It's true. Ugh. There's a bit of extra overhead because we need to store timestamps as well per pixel. So that would bring us up to 7 bytes per pixel. If we add 2 bytes, or X 2 bytes, Y is 2 bytes, color is 1 byte, and then timestamp. The timestamp is not a full timestamp. It's literally just the progress in this 500 milliseconds chunk. So this one would have timestamp 0, and this one would have timestamp 500. So we need 2 bytes for that. So that brings us up to 7 bytes per pixel. Which is 200 megabytes, which is still very, very small. Yeah, the pixels don't need to be full RGB because we're never going to have more than 256 colors. Okay. So far, I'm really optimistic about this. This should be not that bad. Align this to 8 bytes then? Is there a reason for that? Like, does that make Redis faster? What if I wrote a custom database layer and I didn't use Redis? Like, wait a second, chat. I'm talking. Okay. Hmm. I'm talking all this shit about load balancing, about all these pixels going to different backend servers, right? And then there's only one Redis instance, which has to handle actually how many requests per second? Actually, let's see this. How many requests per second? Assume 100,000 people. And every 5 minutes, so requests per 5 minutes is 100,000. Then divide that by 5 times 60. 300. Wait. That's tiny. That's minuscule. I could have one backend. Am I crazy? There could be bursts. This is peak. This is 100,000 people. Ludwig gets 10K viewers. I guess. Oh yeah, I guess there could be. There could be bursts. Yeah. You're right. Mm-hmm. But here's what needs to happen. Here's what. Okay, I understand what needs to happen. Each of the green servers needs to store up a cache every 500 milliseconds. It needs to store the ones that it received and then send those as a batch to Redis. That's what needs to happen. Or Redis or whatever I have running here, because Redis might be slower than whatever I can make because it's not optimized for images. A giant pixel image. So that means that Redis would only be getting 10 requests per second. Or 20. Assuming if there are 10 backends, it would only be getting 20 requests per second. Make the database distributed between the web clients. Great idea. I'll be RB chat. And take a piss. I'm thinking we don't use WebSockets. We use long polling. Or maybe short polling. Because it's not real time. It's batched in 500 millisecond chunks. So if we just send a request every 500 milliseconds, we don't need to worry about the WebSocket overhead. We don't have to have an open connection all the time. Oh, hi, cat. The thing I don't understand is what's the difference between having a WebSocket connection open and having a TCP keep alive? More overhead with sending the headers each time. More overhead for the keep alive. So this is damn. I don't know. So we have two layers. We have the exposed layer, and then we have the internal database layer. For the exposed layer, what's the best thing to use there? Is it WebSockets? WebSockets that send an event back every 500 milliseconds? Or is it something else? Like polling, long polling or something? Which one is faster? Or which one is easier to load balance? You would use WebSockets, but aren't WebSockets bad for load balancing? I mean, just choose your poison. Okay. But I know that can't I there must be some way to take advantage of the fact that I know I'll be getting a request every 500 milliseconds. I will need client-side load balancing? Why would I want that? Why wouldn't I just put a load balancing server in front of here that round robins connections between the Rust backends or the Rust WebSocket servers? Okay, well, the advantage of building it with WebSockets like this is that I can assume for now, or I can test it with a single instance. Sham God, thank you for the prime. The other thing I could play with is having like a worker layer, like Lambda or Cloudflare workers. that connects directly to the big backend. No, but then I can't. Then I can't batch requests into 500 millisecond chunks on each one. I guess I could client-side load balance. Like, there's nothing really wrong with that. Except, I mean, the only thing is it's stupid. It can't access the state of the server, so it can't like automatically go to the ones that are overworked. Can't I multicast? Don't know what that means. Fly.io. Ooh, see, this is what I was asking for earlier. Except, why do they use serifs? That's -1. Might not be a good service. Run a... I don't see no Rust app here. Run from your Docker file. Yeah, I want to do this. Oh, I guess they just have like an extra thing that automatically builds Docker images for it. Okay. I mean, yeah, I guess I'll either just use this or DigitalOcean. God, how many people have posted that blog post now? It's like 20 at least. Okay. What am I trying to do? I feel like having the WebSockets, just multiple WebSockets, one backend. Backend is written in Rust. I read a custom backend here. All the WebSockets are doing is batching writes into 500 millisecond increments. This is what I do. Wait. Every 500 milliseconds, I send a single HTTP request from the backend, or from the WebSockets handlers to the backend. I send all the pixels I've gotten in the last 500 milliseconds. I receive the canvas, and then I send that to all my clients. It's literally just a single call. I send my writes, and I get the reads from the last 500 milliseconds. Then I send these back here. Yeah. Simple, easy clap. The last question is, how do I send the full canvas down? Initially, this can be a bit slow, sending the full canvas. Keep a cache of the full canvas in each WS server's memory and send it on the connection in it. Oh, yeah, because I get back the deltas. Okay, so when the WebSocket servers initialize, they request the full canvas. They get the full canvas back. No, but... Oh, no, because they get the full thing every 5 minutes. Okay, they request the full... This is on boot up. This only happens once. Request the full canvas, get the full canvas. Then every 500 milliseconds, Send the updates here. This is to the same server, but send the updates here. Receive the updates back. Update the cache of the full canvas here. Send the full canvas on wet connection in it. And also send the updates every 500 milliseconds. I think this is good. I think this works. I don't know if it works because I'm no DevOps dude, but I can't see why it wouldn't. Authentication. I have to think about authentication. That's handled on the WebSocket servers. Hey, my cat's on my keyboard. Ray? Just settle down somewhere. So if I have my auth token be a JWT, I don't need to have any database layer. I don't have to do any requests between this and this for auth. What am I using to auth? Good question. I just need something that generates JWTs. So it could be just Firebase, I guess, on the front end. I won't be able to ban bots. Yeah, that's true. But this could peak at 10, 20,000, 100,000 people per second doing auth. I could have a really low expiration on the JWT. And then every 5 minutes, I could have a 10-minute expiration, and then every 5 minutes, well, every 5 minutes is when you place a pixel. So I could just send it with every pixel. Wait a second. Wait. Hold. Pixels are, well, I guess they could peak. There's always going to be more reads than there are writes, though. I could make it so that each pixel requires a new auth token. Real Blackout, thank you for the 6 months of tier 1. Appreciate it. What is WireGuard? Oh, it's VPN. Thought it was something interesting. I think we're playing in a band. Okay. This was always going to be one of the hard parts. I guess I could just have a SQL server for authentication. Wait a second. Hold up. Wait a second. I pulled up this website only so I could draw the logo. Planet scale. Sitting here for sessions. Boom. Fixed. Because writing pixels to the canvas doesn't need to be super high throughput. So basically, by putting auth in a different data store, you plan on having 2 throughput problems. But Planet Scale just will never have problems. Planet Scale, I get 1 billion reads per month for free, and like 100 million writes per month for free, and it's fast and it's SQL, so I don't have to worry about overloading Planet Scale. Planet Scale is just fucking goated. YouTube uses it. Tamanti, thank you for the prime. Or YouTube uses the technology behind it. I don't think they used it itself. Okay, wait. I have to... My cat is exploring my room. She needs to not be going into my cables. We're good. Yeah, so this talks to the database every time someone tries to write a pixel, checks the session validity. Actually, how many 10 million row writes per month. And we calculated that it's 28 million pixels per day. Oh shit, that's a lot actually. $150 per 1 million writes. So that would be $43 per day to handle auth. That's true. I wouldn't write on HRequest. I would only read on HRequest. But I would write... I would write on 100,000 requests. Yeah, wait, okay, this is fine. I mean, of course LUD sponsoring. I'm building this for LUD. I just don't want to break the bank. Wait, but I want... No, I was thinking I want to write on HRequest because I want to write IP data and stuff so I can track bots or something. minus beta. I don't know. I don't know. I'm trying to think about what data I need to store per session. I guess if I use the... Is there any limits on the Firebase API? Admin. Verify ID tokens. This is just checking. This is just checking the JWT. It's not. Rate limiting also. Rate limiting also. I didn't think about that. Authentication is tied to rate limiting. Okay. Well, rate limiting, I can store the session data in Redis. Or, I mean, session in Planiscale. But this does mean that I have a row right. I have to write a row every time I place a pixel. By rate limiting, I mean the pixel rate limiting, not like request rate limiting. So I can't use Cloudflare for it. So I do need to do a write every time I place a pixel, but that's fine because that's only $40 a day. If we have the very maximum 100,000 users each placing on cooldown. Also, I have to end stream at, let's say, 30 minutes from now. Damn, there's too many possibilities for ways to handle this. Is the problem. So I'm kind of stuck deliberating between them. Um, so what if users only had ever one session? Like their session was their user ID and it was also secret. God, I fucking hate people who point me to the r/place blog post. First one was fine. Next 20 were not fine. Um, we are going in circles here. I need to write down what the auth servers or what the web. Okay, WebSocket servers. Accept write pixel. Then it checks auth plus rate limit, and then it writes pixels from memory to backend every 500 milliseconds, broadcasts updated pixels every 500 milliseconds. Okay, so checking auth plus rate limit. What do we want to? How do we do this? Well, I guess we could store a row in our database for every time anyone places a pixel. And then we could, for checking the rate limit, we could check whether or not the latest pixel by this session is more than 5 minutes ago. But then there's a race condition. Because if someone connected to two backend servers at the same time, then they could send a pixel on to both of them quickly, and they would both work. Fuck. How do I solve that? I guess the backend could resolve that. if the backend, because the backend could filter out all the pixels that it receives from all of its children, the WebSocket servers. So how I could handle this, I suppose, is no. How I can handle this is what? Saving the token in Redis and letting it expire. Well, I'm not going to have... My current plan doesn't have Redis in it. This is not Redis. This is custom Rust. But, no, the problem with that is I don't want to have Redis be blasted with 100,000 requests per second, which is our peak. That's the problem. So we can't do that. We don't want anything to be blasted with that much, except for Planet Scale. Planet Scale is the only thing that we can let be blasted with that much data. God, I need to stop looking at chat. You guys are not helpful. When I place a pixel, I want to read the database. The fuck are you talking about? Stop backseat coding if you don't know what you're talking about. Please. Appreciate it. Keep them in memory in the backend. Now that's a good suggestion, possibly. Keep them in memory. So that doesn't solve race conditions for people connecting to multiple backend servers. For multiple WebSocket servers, I guess, actually. I guess I could keep it in memory, huh? Yeah, the backend. Yeah. So so I'm writing all these pixels to the backend in chunks every 500 milliseconds. If I include the auth, if I don't do the auth in here at all, I just assume that everyone is a good actor and sending a valid pixel. Then on the backend, I loop through all the pixels. I save them all to this canvas. Oh, cat. I check the auth of all of them, which I could do in one giant SQL call. I don't know how long that would take though. How long that call would take. Let the WebSocket servers validate the session and send the user ID to the backend. Backend keeps an in-memory map of user ID to last pixel placed. So that would be a row read to SQL. Yeah, okay. But why don't at that point, why don't I just store all the sessions in memory on the backend? That's the question. And then do all the processing on the backend. Because that would put more load on it? How? How so? Like, sure, but like not that much more. 100,000 checks against a map in Rust. That's gonna take milliseconds. I guess millisecond maybe. No, but it wouldn't be in. I would not be using PlanetScale at all. The sessions would be stored in memory. There's no need for PlanetScale if I'm doing that. Did the big announcement happen already? Oh, yeah, that was... No, it hasn't happened yet. Forgot I put that in my title. Uh, what does it need to check when it's checking off? It needs to check that the session is valid, the token is valid. To do that, either JWT or database call. I need to check that session timeout, which has to be a database call. Or from memory. Those are the two things. Or I mean, rate limit. Rate limit. If it's a JWT, faster, but can't ban people. Database, slower, but includes rate limit and can ban people. Session timeout could be signed. I mean, rate limit timeout. You can't, because then I need to issue a new JWT every time. Unless I send a JWT back as when you place a pixel. I guess I could send an acknowledgement back every time someone places a pixel, which has a new token for the next pixel. So I give them, when they connect, I give them an initial token. And then I need a database call for that. I don't know. I think database call is the smartest thing. But the problem with database call is that database call doesn't solve the race condition between, like, if someone's a smart attacker and the same person sends 4 requests for 4 different pixels to all of these 4 servers, all of them would check independently and be like, oh, looks good. And then all of them would send the pixel to the backend. So that's why I think we can't do validation. We can't do session. We can't do authentication. Well, maybe we can do authentication. But then that's why I think we shouldn't have a database at all. We should just hold everything in memory on the back end. Back here, we have a list of every single person. And we have, like, user ID, session token, and then timeout for placing the next pixel. And then when we receive our batch of pixels from all of these servers, we check all of them against this list in memory. Why is this bad? Then we don't need planet scale at all. Yeah, but if the server goes down, everything goes down. If the server goes down, we're fucked. The entire event's canceled. Because we're already reliant on in-memory storage for all of this. JWTs don't solve this either. JWTs don't solve the load balancing bypass either. So we have to do it in the backend. We have to do it in the backend so that we can avoid that. And since we're already reliant on memory storage for everything, why don't we just store this in memory too? The session table of sessions. The question is then, how do we broadcast the auth? We could duplicate this array to all of the users. Well, sure, yeah, we persist the actual image. We back up the actual image. Sure. But everything, like if it goes down, well, maybe we don't even back up the actual image. Because if it goes down, we're just fucked. There's nothing that will save it. We just have to reboot. I could write some extra stuff for trying to make it fixable. But in general, this is written in Rust, so everything should be very, very stable against stuff like that happening. And 2, it's just harder to do that, to make it persistent. 3, this is only running for 12 to 24 hours, right? Each event is only 12 to 24 hours. And the sudden embrace now the question is still, how do we authenticate users? How do the people log in? We probably want to use a different service for it. We could use Firebase and then use Google OAuth, I guess. And then we send Firebase JWTs to the WebSocket servers per request. Yeah, actually that makes some sense. Because we're not doing rate limiting on the WebSocket servers at all. Even if someone sends 10 pixels to the same WebSocket server, it'll be like, okay, sure, cool, I'll send those all to the backend. Or even we could just deduplicate them on user ID. But in different 500 millisecond chunks, right? So if someone sends 1 pixel and then another pixel 500 milliseconds later, so okay, yeah. So if there's one person, this is the bad actor. We'll make them purple. Evil dude. They send a pixel here, and then they send down here, they send another pixel to the same one. Both of those will be sent to the back end because they're in different chunks. And then we're like, boom, 2 people or the same person sent these both. I have this array of all the sessions. Can't do that. Deny the second one. So that solves that. So rate limit is checked here. Auth is checked here, though. So we send a message that has a JWT. And then this pixel that's sent to the back end has the user ID. And then we can also That okay? Then we in this table we have a user ID. We get their timeout, and we can also check like their status. Like if they're automated, then they get to place unlimited pixel, and if they're banned, then they get to place 0 pixel. We do all of that here in the back end. This happens in the WebSockets. Deduplicate. I think this works. Is there any way to prevent voting? We can send the user ID and the IP address here, and then I'll have like a admin view where I can see, ooh, this IP address has received 50,000 IP. Different user. Ban the user. Yeah, only it's just VPNs, but if one person with 4 different Google accounts and 4 different VPN connections, you're not gonna, right? If someone buys 10,000 proxies for the project and 10,000 Google accounts, then all good job. The real place had an issue with people on college campuses and apartments. Yeah, good point. But I mean, I'm not saying we instant ban. I'm saying I have because this is a 24-hour event. I'm saying we have moderators checking it manually. You can't stop client-side scripts. Yeah, I mean, sure. If people placing pixels every 5 minutes on cooldown with a bot script, not much you can do about that besides just detect that they're always placing on cooldown and then time them out or something. To live with dying. Anyway, I think this is good. I think we have a plan here. I need to rate the WebSocket forwarders. Very simple. All the WebSocket forwarders do, they accept pixels, they validate the JWT, and they send those pixels to the backend every 500 milliseconds. Then they receive an updated canvas. They send that to all of their clients. The backend, much more complicated. It stores the entire canvas. Ooh, and this also stores the entire canvas cached. It stores the entire canvas, and it stores the 500 millisecond increments. Persist those somehow, maybe. Not that hard. Very, very hard. Very hard. Good reason there's a reason I told Lutta this wouldn't be done by the end of the month. Yeah, cool. I wanted to react to a video. Yeah, we'll react to this video. One second. Is it in my watch later still? Yes. Nice. Huh. Oh, this is a 30. Okay, we'll watch this at like 1.5 speed. Because I do need to go do other stuff as well. All right, this video is going to be cool. I love this YouTube channel.
Saws at a time, a configuration known as dual wield. Now, an enterprising person could probably manage to put a few more chainsaws on their body, maybe in a one-man band kind of configuration with foot saws and knee-activated saws and a harmonica saw and a head saw. I think maybe this one would have to be duct taped on. And while we're at it, we probably should add some night vision goggles.
Tactical.
But the records for most chainsaws simultaneously brandished were all set by a different technique, which is juggling. Now, you might think that you can equip an arbitrary number of chainsaws by juggling them higher and higher into the air, a configuration known as infinity wield. But unfortunately, once you juggle them high enough, you have to throw them fast enough that they exceed the escape velocity of 11,000 kilometers per second.
True.
And then instead of coming back to you, they just go off into space.
Also
but you know,
true.
we're not limited to throwing these things straight up. We could also throw them tangent to the Earth, shy of the escape velocity, and this will create an orbit where they'll go around the Earth and come back and land in our other hand, which is very convenient for juggling. Here's a computer simulation of that. We can, of course, ignore air resistance, since chainsaws will cut through the air like butter. We get a nice elliptical orbit. And of course, we could pack many chainsaws into this orbit at the same time. Let's see if we can catch it. Oh, well, pretty close. So now we've got these saws shooting by at 11,000 kilometers a second, and we catch and launch them back into orbit. The saws can be efficiently packed in this nice arrangement. And so really what's going to limit us is the
that is a
volume
good
of
arrangement.
chainsaws that we can fit into this reachable area for juggling. So in this volume, we'll see
I don't know
about
how you catch the upside down
55,390
ones,
saws per
but-
second. And since one orbit takes 335.6 hours, we'll have that long before we see a saw a second time. Thus, we're simultaneously brandishing 1.215 times 10 to the 12 saws. This is a configuration known as Terra Wield. Now, I don't have any chainsaws. I live in the city where I have 2 trees, and if I cut those down, I'm done. So there'll be none of that. But we could consider juggling with something that's even more dangerous. Data. Radio waves below 40 megahertz actually bounce off the upper atmosphere, the ionosphere. And they could do this multiple times. In principle, we could make it all the way around the world. We only need to talk about principles here because we're obviously not going to do this.
Yeah, the mountain.
But if you did,
though.
the circumference of the Earth is about 40,000
Imagine the
kilometers,
mountain.
which means that it'll take at least
Or
150
just
milliseconds
cut through the
at the speed of
radio
light
wave.
for radio waves to make their way around the Earth this way. And we can keep transmitting as the data makes its way around the world, which means that by the time we receive our first byte back, we'll have sent something like 750 kilobytes. Then we can receive that byte and send it again. If we have 750 kilobytes in flight all of the time, it's like we're storing that data in the radio waves, like we're using the world as a hard drive. Instead of using radio waves, let's just use internet waves. It turns out that there are computers all around the internet that will send a message back to you if you send them
this is
a message.
genius.
This message is called ICMP echo, to which they'll send an ICMP echo reply. And that message
this is
basically consists of
genius.
a packet that says
I should
what your
use this
source IP
for
address
my-
is
my
and
place
where you're
thing.
sending it, the destination IP. And then there's a payload, some freeform data, which gets returned as is. So I send one of these packets to Australia with my return address on it and some data that I want to quote-unquote store. Then I can discard that data, and when it comes back, you can read it. And I could do this to a bunch of hosts around the internet, and in doing so, store a significant, let's see, amount of data in the internet. So let's do that. And not just that. This is the true story of hard drives we didn't want or need. It's called Harder Drive.
Harder
Nice.
drive. Harder drive.
By the way, this ICMP echo thing is also known as a ping. So I put together some code to send out a lot of pings, and while I was doing that, I figured, why not ping the whole internet? And so I did. By internet here, I mean the IPv4 address space, which are addresses that you know and love, like A.
What about
B. C.
IPv6
D,
though?
each of which can go from 0 to 255. Those are 8
Aren't
bits.
there, like,
so together we have 32 bits, or
sextillions of
4.2
those?
billion addresses. Now, I don't care about IPv6. There's way too many addresses, and most of them
True.
aren't used. Plus, like, call me when you're at least
Okay.
version 7. Am I right? IPv4 is great, and 4.2 billion isn't that big of a number anymore. With my home internet, which is advertised as 1 gigabit per second, I should be able to finish in about 20 minutes. Or, you know, a couple hours, or at most a week. Well, it turns out that sending this many pings was hell on my home network. And not only does it end up dropping a lot of the pings,
Oh,
so
you
it's
probably
useless,
get, like,
it renders the
ping-
whole network completely unusable, which is definitely a no-no for
Wait,
the
how?
work-from-home lifestyle. And I was really only able to push this to about 1,000 pings per second, which is nothing.
Wait, why would this be less of, like, why would it not work? Right? Like, why is it that, like, you have to resolve these IPs and then is your ISP just, like, blocking you from accessing this many different IPs?
It could be that my ISP is throttling me, or there's NAT tables which aren't big enough to handle this many different addresses, or DDoS protection, or I'm just bad at this. Who knows? In any case, I ended up renting some time on some servers and some clusters so that I could finish the job, because the best excuse is that you just freaking did it. So I finished it up, and now we can look at the whole internet. So here is the internet. Let me zoom in a little bit. Actually, let me zoom in.
Oh, that's cool.
Here we have every IP address on the internet. You can see them at the bottom left. And the dot will be white if it responded to my ping, and black if not. And here I've arranged the IP addresses using a Hilbert curve, which is a sort of fractal space-filling curve, which is a standard way to do this. This is not a video about the Hilbert curve. It's not even a video about pinging the internet. There's some somewhat interesting parts here. So this white block here always responded to my pings. That's because it's the loopback address 127.star, which is basically my local computer. So it always responds to that. Up here are a bunch of reserved or multicast addresses, so it makes sense that none of those ever responded. Throughout the rest, we can see a lot of different characters. I'll just give you a bit of a tour, depending on how this address space has been allocated. And each of these corresponds to a different, network, which is broken into sub-networks. This one has fairly fine-grained divisions. This reminds me of a farmland allocation in the United States. That's that square. Over here, we see a network that is very likely to respond to your ping, although there are some blackout regions. This area has all sorts of patterns in it. I actually really like this. We've got some stuff you could print on a tie. We've got some mazes. We got some Tetris pieces. Maybe even some letters here. We got a crossword puzzle. And by the way, this way of mapping the internet is basically canonical, and it wouldn't be that hard to embed some kind of picture or message in here.
I was
like,
just
how
thinking.
cool would it be to embed a little QR code in this, right? Like, it would be a little bit cool. Maybe a little embarrassing, too. Anyway, that's the internet. Probably somewhere in here is your computer, too. And now I yearn to build our first virtual hard drive using what we've learned. This turns out to be no big deal. In Unix, storage systems are abstracted as quote-unquote block devices, which are quote-unquote just files. One way to make a block device would be to implement a kernel module, but then I'd be doing a lot of rebooting. NBDKit, which stands for No Big Deal Kit, is a library for creating network block devices in user space, which you could use for serious purposes or for silly purposes like today's. In order to implement a device, you just have to implement a function like read, which takes some address and a length and returns the data that's at that address, and write, which does the opposite. Once you make one of these virtual devices, you can mount it on the system, you can format it with some file system, and then you can store files on it. Now, the smallest block device that I can make any use of is 51,200 bytes. And to do that, I need to use the FAT12 file system, which is from the DOS era, used for like 5.25-inch floppy drives.
I guess
so what we're going to do is make a device that has
it was 512 bytes per ping. So this is 100 different servers all being pinged.
100 512 byte blocks. Each of those blocks is going to be stored by a number of outstanding pings. And I'm going to use multiple pings per block for redundancy in case one of those pings doesn't come back. I don't want to lose my data. Now, despite the fact that I already pinged the entire internet, I created the list of those hosts by hand. And part of the reason for this is I wanted to make sure I wasn't like hammering someone's cell phone on a metered connection. But also, I want hosts that are geographically diverse, because I don't want correlated failures. And I want them to be high reliability. I want them to respond to my 512 byte pings pretty much every time. But I also want them to be slow. And that's kind of a strange combination. Right? I usually want it to be fast and reliable. Because you're going to get the data back. Slow and reliable. So this wasn't so hard. I searched for things like most popular websites in Madagascar, and I manually just checked them until I found ones that had the desired qualities. Now, you can check the technical report for the implementation details if you want. It is a little tricky to do this because...
He should have done, when he was doing the map of the entire internet, he should have stored how long each ping took and then color the pixels gray, between white and black, depending on that. You'd already have that info.
Since I'm not actually storing any of the data, if someone wants to read from this drive, I have to wait until I receive a ping back before I can process their request. And writes have a similar challenge. The biggest problem here is the aforementioned throttling to about 1,000 pings a second. I barely got this working, but it would have been nice if I could send a few million pings per second instead of 1,000. I also built a UI for this thing, which we'll see in a second. So now what I want to do is stand up the drive, and I want to benchmark it to see how well it performs. In order to do that, I need to figure out what data I want to store in this drive. So I decided a fitting file, one that is a kind of improper hierarchy, would be RFC 792, a text file that describes the Internet Control Message Protocol, ICMP, echo, and echo reply that we're using. That thing is 30 kilobytes, so it just barely fits on the drive. So here it is running that benchmark. The white blocks are healthy blocks. Those are blocks where we have the full target number of pings outstanding. If a block isn't white, that means we've lost a ping, and then it's in danger of failing. And that will happen all of the time. The crossed out blocks have not yet been written, so they don't have any data. The red dot indicates a block with an outstanding write, so you'll see that move around as the benchmark goes, and a green block the same for reading. At the bottom, you can see some of the hosts and statistics. I keep track of the statistics on the host so that I don't overload one host, and if it becomes less reliable or too fast, then I try to avoid using it. After the benchmark finishes, I guess there's a hiccup in the system or something, and I actually do lose some data. So a couple of these blocks die and don't come back. That will happen. This is not a reliable way of storing data. But we can look at the file that I stored and read that protocol description. You'll see right here, there's an area that was lost. It's all zeros now. But the benchmark did work completely, so we can get some numbers. But I don't just want to evaluate these drives by their speed. Let's also consider the qualitative aspect. Qualitatively, this is a pretty good hardware drive. It does solve a problem that we don't have.
True.
Which is to pretend we have a fast network but no memory in which to store data. It treats latency as a desirable quantity, contrary to the usual preference. and it was harder to make than I expected. The cost is not too bad. I have to have a computer, but I always have to have a computer. My home network costs about $80 a month for 1 quote-unquote gigabit, and this is about as much as I can store before the thing fails. So this ends up being about 0.15 cents per byte per month, which is not too bad. Longevity, however, is poor. The benchmark succeeds with 100% accuracy, like I mentioned, but the data is lost readily if you leave it running for a few minutes. And since we store the data externally using untrusted hosts, they can just send back whatever data they want and corrupt the drive. On the other hand, since we don't store any data locally, we could consider this non-volatile storage, in the sense that if we completely lose power, the data still exists as long as we can reboot in about 100 milliseconds
only
to
until it
receive
comes
the pings
back.
as they arrive, which is kind of unlikely. The speed is pretty slow. I got about 14 kilobytes a second reading and writing, which are basically the same operation. The power consumption for me is low, but the internet itself actually uses a lot of power. A typical undersea cable is excited with power on the order of tens of kilowatts, and they have repeaters every 100 kilometers or so, which is a lot of power. There's a lot of juice. If I was the only one using this, it would be very, very inefficient. Fortunately, many people are using the internet, and these pings are a tiny fraction of the bandwidth. And if I assume that my internet bill covers the marginal cost of the power for the internet, which makes sense, then it turns out to be about 5.8 microwatts per byte.
Not that bad.
In terms of harm to society, the drive is definitely harmful to my home network. Whether you can consider that a positive or negative to society is left as an exercise to the reader. At this scale, it's a trivial impact on the internet at large, but if we were to do this to store many terabytes of data, or if everyone were doing this, it would be pretty bad for the shared infrastructure. And we're kind of freeloading off the willingness of other hosts to respond to our pings, and so that would be somewhat antisocial. Speaking of antisocial, I'm sorry to remind you about Vladimir Putin's illegal invasion of Ukraine, but this section concerns a hard drive made from Soviet blocks. And when I say that, of course I mean Tetris.
Ole Sostkides.
Okay.
Sostkides.
Tetris is an inventory management survival horror game from the Soviet Union in 1984. It features
Inventory management. Okay. Yeah, I can see that. I can see that.
19 principal characters, which are these. And like all living things, they're made up of pixels or blocks, so we can make a block device out of these. The Tetris playfield is 10 squares wide and 20 squares high. So the idea is to draw some pattern inside the playfield which will encode data.
Oh, I see.
And we can of course do this in multiple rows to encode several bytes within the playfield. Now one thing to notice is that we can't fill up an entire row, that is all ones, because that clears a line in Tetris. It's also impossible to leave a row entirely empty unless there's nothing above it. So a row of all zeros is also impossible. A less obvious thing to note is parity. Because dropping a piece adds 4 blocks, and clearing a line removes 10 blocks, and these are both even, the board will always have an even number of blocks on it. That means we can't store a byte with odd parity on its own. So I only store 8 bits per row and leave the first 2 columns for parity and support.
Smart.
That way we don't need to store any completely empty or completely full rows, which are impossible. Speaking of impossible, it's pretty hard to play and create arbitrary patterns, especially floating blocks. But that's the essence of harder drives. In order to make this easier, we want to get rid of one big obstacle, which is if you're getting pieces at random, it makes it really hard to plan out your strategy. Even when you're playing this game normally, not getting a line for a long time can be a real drag.
He's gonna manipulate
So the first step
RNG.
is going to be to reverse engineer the random number generator of the
Oh,
game
let's
so
go.
that we can control what piece we get. Today I'm going to be working with Nintendo Tetris for the Nintendo Entertainment System. This game has a random number generator that's updated every single frame and determines the next piece at the moment that one lands. And that means that if I take more or less time as I drop a piece, I can influence what piece I get. The core of this routine is something called a linear feedback shift register. Equivalent C code for that thing looks like this. You have a 16-bit number, you shift it over, you pull out some of the bits and XOR them together, and then the result of that goes in the high order bit. The setup is really simple. It has a period of 32,767 before we see a repeated state, and that's pretty good. Incidentally, part of the reason we know this is that Solomon Golom, who studied these things and wrote the book on LFSRs, also wrote the book on polyominoes, which are a generalization of tetraominoes, and apparently that book inspired Tetris. So it's fitting that his work appears inside the source code of the Nintendo
Fitting
version.
indeed.
That said, it is possible to do better than this. It's known that you can have a period of 65,535 if you'd use different constants. This is one of several deficiencies I found in Tetris as I was reverse engineering it, and it would be easily fixed. Maybe one day I'll release a version 1.1 hotfix. Now let's look at how that random number generator is used to generate random pieces. Equivalent C code is on the right, but I want to show you this diagrammatically. The first thing we do is take the random state, add to it the number of pieces we've dropped so far, mod 8, and that gives us essentially a random dice roll from 0 to 7. Now this number is pretty random. Actually, in any given state, the maximum I would ever have to wait before seeing the number that I want is 98 frames. But most of the time, I'll get the number that I want after a dozen frames or so. The histogram looks like this in case you're curious. So if that were the whole thing, this would be easy. In order to get a certain piece to come up, I just wait a certain number of frames until the next piece will be the one I want, and I'm done. But here's the rub. There are 2 cases where I roll a second die. First is if I roll a 7. Second is if I would drop the same piece that I just had. The goal is to make that less common. In each of these cases, I update the LFSR again, and then I use it in some other wacky formula to roll a 7-sided die. And this time, I don't care about duplicates. I just take the piece that I roll. Now, I can kind of understand why they wrote the code the way they did here, but it actually contains some serious problems. One of them is that in some conditions, it's impossible to get a duplicate piece. For example, on the third piece of the game, if I just saw a line, it's impossible to get another line, no matter how long you wait. Now, the reason for this is that although superficially you're rolling two different dice, and so it should be fine, you just need to get lucky, consecutive dice rolls are actually really correlated.
Oh, because it's
if we go back to this
shifting
guy
the
who,
bytes.
by the way, knew about this problem.
The same bytes are
This
there.
red region here is the part of the shift register that's used to produce the output value. And we can see that in two consecutive states, two of the bits are going to be exactly the same. So there's not that many combinations of two consecutive dice rolls.
Ooh.
This is also a fixable problem, but we got to work with the game we got. So this adds a constraint for us, which is that as we form a plan to drop pieces to make our pattern, we really ought to avoid duplicates completely so that we don't get ourselves stuck. Other than that, because
I don't understand why there's an extra 7 though. Like, why don't they just roll a 7-sided die here, and then if there's a duplicate, roll it again?
the value of the random number generator, we can ensure that we get the piece that we want at just the right time. So next up is to figure out how to use those pieces to generate the pattern to
Fix your
encode the
game,
information we
Nintendo.
want on our Tetris hard drive.
SMH.
I solved this problem in a modular way. What I do is initialize the board to a known position, and then for each byte, I'll find a sequence of moves that puts that byte on the board, given the known position, and then puts it back in the known position. The very beginning of the game looks like this. I always play these same sequence of moves, which clears the board and then places that S shape
Oh, because
in
you
the leftmost
can
column.
manipulate the
Each
RNG,
byte's
so you
plan
can
will only
always
be able to assume
guarantee
that
you
S
get
is
those
there, nothing else
pieces.
about the board. You'll see a little hesitation on the pieces sometimes. That's it deliberately waiting so that we get the drop on the right frame, and thus get the right random next piece. We just wrote a couple zeros to show how this next part doesn't depend on any support below it, and the board is now back in that standard position. Next, we're going to write the byte 2e, which in binary is 00101110. Sometimes when we reach a very long drought with the RNG, which can be up to 98
Pause.
frames,
Okay.
we actually pause the game in order to slow it down even more, which is annoying. Now the bits are in the correct place, but we need to clear the garbage that's above it and put it back in standard position. And then we can just repeat that process over and over again to write bytes into the field. Of course, one Tetris game storing 8 bytes is not enough for a hard drive. So we can do this on many Tetris boards simultaneously. Here's a demo of that. I'm highlighting only the parts that encode the data, or here are some letters and drawings. By the way, I found the solutions for each byte by a computer search.
That's so cool.
It's not that hard to find a solution, but finding a small solution takes a lot of time, at least with my algorithm. I
There's
plotted
a
the length
smiley
of the best
face.
solution for each byte in this graphic, where the first row is the byte 0, then 1, and so on. And lighter cells use more moves. There are some symmetries and patterns visible, but I was somewhat disappointed not to see the familiar Triforce pattern appear here, as it has so many times before. It might be that the solutions are not quite optimal, but they're probably close. Alternatively, it could simply be that this is the exception that proves the high rule. But this is also not even close to enough Tetris games to store a file that's of interest. And here the most beautiful choice of file to store is the Tetris ROM file itself, which is 49 kilobytes.
True.
So I need 8,640 NES emulators, which is not really that big of a deal, except for trying to fit them all on the screen so that I can visualize this thing.
I
So
see.
here's that thing running the benchmark, which is writing Tetris.NES onto those 8,640 emulators.
That's
That
so
takes
cool.
several hours to finish, but it does work. It's actually very reliable. Each one of these is a real Tetris game, although it's being rendered with individual pixels.
That's so cool.
To read the data out, we just inspect the memory of the emulator, which has the Tetris playfield at a particular place in memory, so that's easy and fast. After the benchmark finishes, with the file still written to the drive, I can load up an NES emulator and load the Tetris game and play it off that drive as it's being stored in the 8,600 other emulators.
Let's go.
So here I am doing that.
Then
And
you just
ironically, I had a
need
really long drought with no eye shapes here, so I only have 100 points. But you
to
can see
make
I'm
a
gearing up
Tetris game
to
out of
score some sweet
or
high-scoring
make
Tetrises.
that drive out of
Let's see how
Tetris
it stacks
games
up.
out of
Looking at the qualitative aspect
drives.
again, this is another good harder drive. It solves a problem we don't have, which is to make a hard drive, aka a block device, with a triple entendre, the Soviet block. Implementing it meant solving several decent computational problems, which I enjoyed, and it's satisfying to watch it go. The cost is not too bad, mainly because computers are really cheap. Each Nintendo emulator takes 1.6 megabytes of RAM, which could definitely be improved, but that's what we got. And so I can store about 5,200 bytes per gigabyte of the computer RAM. At today's costs, that's about 0.084 cents per byte. The longevity here is normal. The data doesn't rot or corrupt over time. But if you turn the computer off, everything is lost. On the positive side, because everything is stored locally, bandits do not have any access to the data to read it or tamper with it.
Nice.
The speed is pretty bad. We write the 50-byte Tetris ROM in 3 hours and 18 minutes, which is
Oof.
2.57 bytes per second. Reading is pretty fast, though, because that just comes right out of the Nintendo's memory. Power
That's
usage
nice.
is similarly reasonable. A gigabyte of RAM is about 375 milliwatts, so this works out to 72 microwatts per byte. We could compare this to the same thing running on a real Nintendo Entertainment System, which could store 1 byte in about 1.25 watts.
That's pretty
The
big.
hardness society depends on whether we do this on a computer in emulation, in which case there's no harm, or by scooping up thousands of classic consoles and cartridges on the secondary market. In this case, it would be harmful. Many people still like to use these consoles for their intended purpose, and hoarding is unethical.
Also, you can't read
Now, speaking
from
of using things for their intended purpose, I'm sorry to remind you of the global pandemic still killing thousands of people every day. But this next section concerns a hard drive made of used COVID-19 tests.
SARS-CoV.
them. Okay.
SARS-CoV.
Q is a bougie COVID-19 test from 2021. The test
Okay.
consists of a reusable reader, which costs $200, and a single-use cartridge, which is $65 each. You insert a nasal swab, it runs its little lab on a chip. It's actually quite cool, notwithstanding the eye-popping cost.
That is
My
cool.
workplace lets us test regularly for free. So I started collecting the used cartridges over the course of several months and soliciting them from my friends as well. Now, two different
Okay.
colors of gray could in principle encode data, but these sticks get in the way, and it's just not satisfying. We could admire the cartridges on the dry salt bed for eternity, but they're actually quite ingenious and deserve to be disassembled. I recommend only doing this to negative tests.
True.
When you stick the nose
Good
swab
point.
in, it of course delivers the snotty sample. But the insertion also mechanically moves these thorns and rips open these foil ampules which contain reagents. The assay is described as nucleotide amplification, which suggests something like PCR. But it doesn't significantly change temperature during a test, so it's probably not literally PCR. I think it's probably LAMP. After it's amplified, I think it
I don't know
flows
what
through
that
this channel here
means.
so they can detect the result. And finally into this sponge for safekeeping.
This is
If you pull
cool.
off all the chemistry pieces, though, you'll find that there's a tiny 8-pin microchip on board. And if you have really good eyesight, you can read that it says ST24C04WP, which is a serial EEPROM. This is a programmable read-only memory, so it's read-only but also writable. It's probably used by the system to store calibration data, maybe expiration date or something. After soldering tiny wires onto these tiny pins and writing a driver, I had hoped to see some secret message congratulating me on my steady hands, beginning an alternative reality game whose prize was the inheritance of an eccentric billionaire. I probably wouldn't have time for that anyway. There doesn't
That'd
seem
be
to be
cool.
anything actually interesting in the ROM, but that doesn't mean we can't put something of our own that's interesting on the ROM. Now, unfortunately, this thing only stores 512 bytes. So in order to make a hard drive that can store something interesting,
Of
we're going
course.
to need a lot of them. And then we're going to need to hook them up somehow. I made a circuit board to hook these cartridges together. The EEPROMs are I2C devices, so they could in principle be on the same bus. But unfortunately, they're all the same, and so they have the same address. This means that I actually need to use bus switches. That's this component, to connect and disconnect them from the bus. Those switches are indexed by a demultiplexer, which takes 3 address bits and selects one of the 8 Q cartridges on a board. Each cartridge has this custom mount, which is a little bit tricky to design. The card edge is supposed to slide into some spring-mounted connector, but I wanted to solder them directly. So I made some fine castellated edges. Unwisely, I decided to add decorative LEDs, which would show which Q cartridge was activated at any given time. This accounts for most of the complexity of the circuit board. Finally, I made a whole bunch of these boards, which are all identical. One of
Worth
them
it
has an
though?
additional section populated.
Probably.
This connects to the Raspberry Pi and so on. This is a nice design because I had to order these things
How
in
many do
quantity.
you... Oh,
So
no.
all of them have this vestigial part that's only used one time. Assembling the boards is labor intensive, but not that hard. The only tricky thing is these
How many
custom
does he
connectors.
need?
So I 3D printed a jig to hold the Q cartridge at a 90-degree angle while I was soldering, which helped a lot. Then I
must have
made some custom
taken
enclosures and wired
hours.
them all together.
Years.
And hours and hours and hours later, on the eve of the Sigbovic deadline, this happened. Well, not this is a reenactment. But it did die. I completely fried the Raspberry Pi. Fortunately, I had a backup. And then I did it again.
Oh no.
This caused me to realize it was not simply some kind of fluke. Who would have guessed that this janky sealing outlet would have been wired incorrectly? Anyway, I used up my last 2 Raspberry Pis, and it's impossible to get more right now.
Supply chain.
So unfortunately, we're unable to benchmark this device.
Oh no.
But we can still evaluate it. I would say that this is a decent harder drive. It definitely solves a problem we don't have, which is that I want to keep around all these used COVID-19 tests. It was also a large effort, although most of it was just about soldering really small stuff, or repeating the same action over and over and over again for hours.
But you are storing
On the other
memory
hand,
on
EEPROMs
a...
fundamentally store data,
Yeah.
so it's not that weird to use them as a hard drive.
True.
It could, however, be described as very silly, given that a single 1 megabyte NAND flash chip costs about 30 cents. On the other hand, mucho demerits because it doesn't work, at least as a hard drive. But on the other hand, it does work as a smoke machine.
Oof.
The cost is significant. Here's the bill of materials
Oh yeah,
per
'cause
board.
it's just
The main thing is the
$65.
8 COVID tests, which cost $65 each. But there are a number of other components, including the custom PCB, totaling about $531 per board. This doesn't even count the hour or more to assemble each board. For a system large enough to store the SARS-CoV-2 genome, it costs $6,936.
Sheesh.
All told, it costs a little under 13 cents per byte. This is the only drive we considered where data is retained when it's powered off. So that's great. The datasheet for the EEPROM rates it at 200 years of data retention, which at this point is probably going to outlast human civilization. Due to explosion, the speed of this drive is currently unknown. The power consumption is excellent. The Raspberry Pi, when it's working, uses less than 3 watts. And the incremental cost of adding a byte comes mostly from the EEPROM, which comes out to about 19 nanowatts per byte. We find that this drive is actually
That's
beneficial
tiny.
to society. For one thing, it's made from trash. Testing helps prevent the spread of disease and saves lives. And finally, because the tests contain captured body fluids, this brings a much-needed human element to computing.
Nice.
Speaking of captured body fluids, get out your barf bag because it's time for another round of Things Tom Hates. The name of this stock app, Think or Swim. It's of course a play on the idiom to sink or swim, meaning metaphorically to toss someone into deep water to survive by their own efforts or else drown.
Shouldn't
Makes
it
sense
be
for an app that
sink
lets
or
consumers
think,
trade derivatives,
though?
but the obvious problem here is that if it's think or swim, then are we now asking the subject to survive by their own efforts, i.e. swim, or else think? Huh?
Yeah.
Or is it they must think carefully about their
Cringe.
trades or else they will survive? What? 2. Poison ivy. There's just no point to this plan. 3. Cryptocurrencies. I have no
Ooh.
objection to cryptography. and
Hell yeah.
finance. I actually love cryptography. I read this whole damn book in college. But the current scene is just vomitous. Cryptocurrency significantly harms the planet while taking advantage of people's technical and financial illiteracy. Now, it's hard to avoid noticing the common prefix of blockchain and block device. So a head-to-head comparison might be instructive. Let's look at Bitcoin, the most popular cryptocurrency.
Okay.
It's append-only by design, but it does store data, namely the transactions. For comparison's sake, we'll consider usage where the head of the blockchain contains the full data, a write is accomplished by mining a new block, and a read is accomplished by reading the head of the chain. For Bitcoin, the block size is just 1 megabyte, and the network automatically adjusts to mine 1 block every 10 minutes. I did not actually implement this both because of the gag reflex and because I don't have that kind of money. Despite hating it, I must admit that Bitcoin makes a pretty good harder drive. It solves a problem we don't have, which is to imagine a world where we can't find a few trustworthy parties, the majority of whom are acting in good faith. The solution is elegant in the small, putting aside its obvious fatal flaws, and comically absurd when taken to its logical conclusion. It's impressively wasteful, and it gets more wasteful automatically. In short, it would make a solid Sig-Bovic paper. The only problem is that people are using it in seriousness and all of the social problems that entails. Power is, of course, catastrophically high. It uses 15.74 kilowatts to store 1 byte. Just the act of mining uses almost 1/3% of the entire world's energy consumption. And all this accomplishes is proving that you wasted energy so that you don't need to trust a bank or a set of banks. The longevity is very good. Nominally, the data can't even be erased. Of course, the data are stored by adversarial bandits themselves, and if a colluding majority decide to do so, they can just change the data to anything they want. The cost is pretty high, especially for the power. Mining a single block yields about $342,000 in March 2022, so if we assume that's profitable, that's a maximum of 34.2 cents per byte. The drive is pretty slow at 1 megabyte every 10 minutes, but it is at least faster than the hard drive made out of Tetra simulators, so score 1 point there. This is approximately as fast as one 14.4 kilobit modem.
That is one good thing about Bitcoin,
The harm to
I guess.
society is significant. Aside from the catastrophic waste of resources, the primary use case is speculation on the currency itself, or on dubious certificates of authenticity for JPEGs. As a slow, expensive, non-atomic, yet irrevocable payment mechanism, cryptocurrency is best suited for extortive transactions like ransomware. Okay, alright, thank you for indulging my tirade. We're mostly here to have fun today. But remember that technology has a large impact on society, and we as technologists have a large influence over that. Speaking of fun, you might ask, Tom, that looks like a lot of hard work. Why go through all that trouble? And to that I say, we do these things not because they are hard, but because they are harder drives.
Harder drive. Harder drive.
Good video. This guy is amazing. This channel is really sick. All of his videos are like this. I highly recommend. Anyway, I have to go. Because I have to do a presentation soon, and I haven't started making it yet. So thank you for watching the stream. We will soon be doing more stream. Also, if you want to like recommend this video to other streamer who would like it, do that because this guy's sick. I'm gonna raid Point Crow because he's doing a subathon and I made the timer for it. Thank you for watching. Oh, announcement when? Oh, tomorrow. Announcement tomorrow for sure.